Welcome viewers. In this video we'll see the details about voltage regulation of alternator in ASA method, that is American Standard Association method. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic, ASA method, voltage regulation of alternator. We know that there are so many methods available for voltage regulation of alternator. EMF, MMF methods are available. There are some errors are available in the EMF and MMF method. The errors are, these tests are done based on the assumption that magnetic circuit is unsaturated, but in practice magnetic circuit is saturated. So we assume unsaturated condition, but practically it is saturated. So that is one of the error. The next one is, in salient pole alternators, the armature and field MMF cannot be added vertically due to the variable reluctance of the air gap. And also the field winding is connected in the pole core and the armature is distributed. Therefore, phase combination of field and armature is not fully justified. Right? So these are all the another disadvantages. To overcome this, we are using the ASA method, American Standard Association method. Now we'll see the procedure. So first we need to draw the OCC curve from OC test and ZPF, zero power factor curve, and Portier triangle PQR. So this ZPF curve, Portier triangle, separate video available. From that we can able to understand what is the procedure. Now we'll see the graph, then we'll go to the procedure. While after seeing the graph we are able to understand. Now we'll see the graph for ASA method. So this is the graph available for ASA method. X-axis the current, field current is there, Y-axis open circuit voltage is available. The first step is we have to draw the OCC curve from the OC test. Separate procedure available, separate video available how to draw the OCC curve. And ZPF curve. We have to draw the ZPF curve. Then we have to draw the Portier triangle, PQR. So these are all separate videos available. You have to draw the PQR Portier triangle. Then we have to draw the air gap line. Air gap line is nothing but tangent of the OCC curve. The tangent of the OCC curve is nothing but air gap line. Right. So first we have to draw OCC curve, ZPF curve, Portier triangle, then air gap line. The next step we have to find the rated voltage. By using the formula, we'll see the detailed procedure. We have to find the rated voltage. From rated voltage, draw the line. Where it cuts the air gap line, draw the horizontal line, drop the line. Where it cuts the x-axis, that will give the F0. This PS value is nothing but FAR. So from the Portier triangle, you are able to find the FAR. From rated voltage, draw the line. Where it cuts the air gap line, draw the perpendicular line. Where it cuts the x-axis, that will give the F0. So now with this F0 value, then we have to find the E phase. E1 phase, we need to calculate the E1 phase using the formula. Separate formula available. We'll see what is the formula while seeing the procedure. So E1 phase we have to calculate. From E1 phase, draw the line that will cut the air gap line and OCC. Air gap line at point B, OCC at point B0, B dash. So we got the 2 points B, B dash. So we have to add this B, B dash with the FR. This FR is calculated by adding FR with B, B dash will give the F dash R. So that's doing the procedure we are able to see that. From FR, draw the line, vertical line. Where it cuts the OCC, draw the horizontal line. Where it cuts the x-axis, that will give the E phase. By using the E phase, we are easily able to find the regulation of the alternator. So I will explain again. So x-axis current, field current, y-axis OCC, draw the OCC curve, draw the ZPF curve, draw the Portier triangle PQR. In that, PS is nothing but FAR. Find the V rated using the formula. Draw the line, horizontal line. Where it cuts the air gap line, draw the vertical line. That will give F0. Then find the E1 phase using the formula. Draw the horizontal line. Where it cuts air gap line is B. Where it cuts the OCC is B dash. The sum of FR and B dash will give FR dash. From FR dash, draw the vertical line. Where it cuts the OCC, or draw the horizontal line. That will give E phase. This E phase, from using the E phase, we are able to find the regulation of the alternator. So what we discussed, now we'll see the procedure step by step. So the procedure, draw the OCC curve from OC test. What we discussed, the description is there. Draw the ZPF curve and draw Portier triangle PQR. From Portier triangle, find the value PS equal to FAR. Draw the air gap line. Then find the V phase. That is nothing but V line rated divided by root 3. So from the value of V phase rated, extend to the line to air gap line. At the point where it meets the air gap line, that will give the corresponding value of F0. So this is a diagram what we discussed earlier. Then we'll see the next step. So we got the FR from this air gap line. So using that FR and FAR already available from the Portier triangle. F0 we calculated from air gap line. Using that we can find the FR value using the cosine rule. FR equal to square root of F0 square plus FAR square minus 2 into F0 FAR cos 90 plus or minus pi, plus refers lagging power factor minus refers leading power factor. So for this FR value is available now. So F0 and FAR, that will give the FR value. Using this only we calculated using the cosine rule. Now we need to find the E1 phase value using the formula, or E0 air gap. E1 phase equal to V cos pi plus IA RA the whole square plus V sin pi plus or minus IA XL the whole square. Right? So this, using this formula we can find E1 phase, plus refers lagging power factor minus refers leading power factor. So if IA XL is not given in the question, we can find from the Portier triangle PQR, RS equal to IXL. If it is not given, we can able to find. Corresponding to E1 phase, draw the line parallel to the x-axis. It meets the air gap line at B and OCC curve at B dash. So we got the 2 point B dash. Add the value of B dash to FR, that will give the FR dash. So FR dash equal to FR plus B dash. So this diagram is available. F0 FAR, vector sum of these two is FR. By adding B dash, we will get FR dash. So from this FR dash, draw the line. Again we need to draw the line. Corresponding to field current FR dash, find the value of E phase. Once E phase is calculated, we can find the regulation using this formula. Percentage regulation equal to E phase minus V phase divided by V phase into 100. So we discuss here the ASA method to find the voltage regulation. And one more method is there. One more procedure is there, graphical method. Now we'll see how to find using graphical method. So this is a graphical method. First we will refer the graph, then we will see the procedure. So here IF, x-axis IF is available, y-axis open circuit voltage. So here also we have to draw the OCC curve first. Then draw the air gap line that is tangential to the OCC curve. take the x-axis. We are taking x-axis as a reference. The IF is there and also IA. IA also in reference with the x-axis. Then draw this line that is leading power factor IARA with an angle of pi. Draw this line. Now draw the IARA drop. This IARA drop in phase with the IA. So this is in phase with the IA. Then we have to draw the IXL, that is 90 degree to the IA. IARA in phase and IXL in phase 90 degree to the IA. Now we have to draw this curve. We'll see how to draw that. Calculate the value of E1 phase using the formula. E1 phase is calculated. From E1 phase we got the value OD. This O as a reference and the D as a radius. D as a radius, right? So while calculating E1 phase we got this value OD. So draw the line, this OD, O as a center and D as a radius. So where here we got the point M. We got the point M. After while drawing this curve, we got this point M. From this M, draw the line, horizontal line. Where it cuts air gap line is B. Where it cuts the OCC curve is B dash. So by adding B dash with the FR will give FR dash. This is FR. By adding with that B dash will get FR dash. That is, this is nothing but FR dash. From FR dash, draw the vertical line. Where it cuts the OCC, draw the horizontal line. Where it cuts the XY axis, that will give E phase. From this E phase value, we are able to find the regulation of the alternator. So this is the graphical method. So first we are taking x-axis as a IA as a reference, y-axis open circuit voltage with the leading power factor of pi. IARA drop is drawn. IXL drop is drawn with 90 degree with the IA. And then we have OCC curve and air gap line is already available. This with V rated we are able to find the F0, that already we know that. E1 phase is calculated, so that we got this value. The curve is drawn. That point is nothing but M. Then draw the line that will give B dash. B dash is added with FR, that will give FR dash. From FR corresponding value what we got is E phase. Using E phase we are able to find the regulation of the alternator. So what we discussed, we'll see the procedure one by one. Description is available. Draw the OCC curve from the OC test. Draw the air gap line. Take x-axis as a reference for a current IA. Leading IA, x-axis by an angle of pi, draw the voltage vector V. Draw IARA drop in phase with IA. Then draw IXL drop at 90 degree to IA. So what we discussed, the description is available. We'll see further. So the next step, we need to find the E1 phase. That is nothing but V phase plus IARA plus IAXL. So that will give the point OD. With O as a center and OD as a radius, draw the arc that will meet the y-axis at the point P. From point P, draw the line parallel to x-axis to meet the OCC curve that will meet B dash and at a air gap line at B. OCC curve at B dash and air gap line at B. So we got the point B dash. Using the cosine rule, we can add FR plus B dash will give FR dash. From FR dash we are able to find the E phase. Using the E phase value we are able to find the regulation. Regulation of alternator equal to E phase minus V phase divided by V phase into 100. So in this method, we discuss the voltage regulation of alternator, ASA method, American Standard Association method. First we will discuss the normal procedure, then we will discuss with the graphical method. Our final aim is to find the E phase value. From the E phase value, we are able to find the regulation. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening. All the best for your examination.